Hello, in this video, we're going to be using what we've learned about proportions, ratios, and proportions and apply them to some real-life examples. Practical applications of solving proportions, another way to say it. So, for number 9, the gear of a bicycle has an 8:5 ratio. So let's write that down. 8:5, because this can be written as this, as you remember. This means that for every for every 8 turns of the pedals, the wheel turns 5 times. So this is saying for every 8 turns of pedal, the wheel turns 5 times. So 5 times turn on the wheel. You don't have to write this all out, but it's nice to know like what variable is going on, like not what variable, but what the 8 is saying, what the 5 is saying. So the 8 is saying 8 turns of the pedal. Per every time you turn the pedal 8 times, the wheel will turn 5 times. All right. So if a bicycle turns, so the question's asking, if a bicycle turns 2,435 times during a trip, how many times would you have cranked the pedal during these trips? So it's saying, okay, for every turn, so for every 8 turns, the wheel is turning 5 times. So every time you know when you're on a bicycle and you pedal 8 times, it's basically saying every time you pedal 8 times, the wheel would have turned 5 times. So they're asking, what if the wheel had turned 2,435 times? How much times would you have pedaled? The long way to do it was to actually make sure the wheel turns 2,435 times and then count how many times you pedaled. But that's almost impossible. You're likely to make an error, so don't try it. Let's do the math way. Okay, so let's set up the ratio again. So 8:5. The 8 is saying the turns of the pedals. So this is how many times you turn the pedal. And 5 is per every 8 turns of the pedal, how many times the wheel is turning. So 5 equals, so we know that means the wheel turning goes on the bottom, and the 2,435 is referring to how many times the wheel turned in that trip. So it also goes on the bottom. It's asking how many times would you have to turn the pedal in order to get 2,435, given that when you turn it 8 times, you get 5 turns on the wheel. Okay, so really what we're looking for is how many times you have to turn the pedal. So now we have an equation. So now you can multiply out using the relationship. So a times b, which is 5 times x, equals 8 times 2,435. Just quickly use a calculator for that. 8 times 2,435. That gets you 19,000. Wait, come back here. 480. Now divide by 5 or multiply by 1/5. X equals, so 3,896. So basically we're saying that if you were to pedal 3,896 times, the wheel would have turned 2,435 times. Let's check this value. So put it back into the equation. 8/5 equals 3,896, our answer, over 2,435. So, okay, this is a pretty big thing to simplify. Well, a good way to do it, if you don't want to simplify it via fractions and reducing, what you could do is just make sure that 8/5 does equal that. So 8/5 is 1.6. 3,896 divided by 2,435 is also 1.6. So this would have reduced to 8.5 because they both equal the same decimal. So we did the equation right. All right, for this question here. It takes 7 minutes for Isabella to walk around the gym twice. At this rate, how many times will Isabella walk around the gym in half an hour? So let's write the first ratio. It gives it to us. It takes 7 minutes to walk around the gym twice, per walking around the gym twice. So twice, try that word. Yikes. Okay, 2 times around gym. So per every 7 minutes, she can walk around the gym twice. At this rate, because a ratio is a rate, at this rate, how many times will Isabella walk around the gym in half an hour? And half an hour is just 30 minutes, right? So minutes go on the top because it is on the top in here, and this is a proportion. You're finding what it will be a proportion, therefore the minutes have to both be on the top. So 30 over. And you're trying to find how many times, and times goes on the bottom, how many times will it take her to get, how many times will Isabella walk around the gym in 30 minutes, or half an hour? So let's set this up as a proportion down here. 7 over 2 equals 30 over x. Multiply this out, or you can call it the means extremes theorem. A times b, so 7 times x, well, sorry, a times d, 7 times x equals 2 times 30, so 7x equals 60, and x equals 60 over 7. Now, usually you could leave it like this, but since it's a word problem and it's asking how many times, I mean, it's kind of weird to say, hey, how many times? And you say, well, I went around the gym 60 over 7 times. You're not going to know what you're talking about. So it's, if you have a calculator, you can turn this into a decimal. So 8.57, which makes a bit more sense. So 8.57, which is roughly 8.6. So like Isabella, per every 30 minutes, she can walk around the gym 8.5 times, roughly. I'm going to pause now. I'm going to test you and see how, I'm going to let you try to set this one up by yourself. Just set it up, then I'll go through it with you. Okay, so it's saying on the model plane, the scale is 5 centimeters equals 2 centimeters. If the wingspan of the scale model is 28.5 centimeters, what is the actual wingspan? Two things to note. One thing is not very important. One thing to note that what's not very important is that this is a pretty small model, because 5 centimeters going to 2 centimeters, that's like this going to that. So not a very huge model, but that's not really important. It makes the math easier if it gets for this word problem to make it a small model. So let's set up the proportion. So for every 5 centimeters on the bigger model, because obviously the bigger model will have the bigger measurement, so it's actually good to draw a picture for this one. So let's say a plane, not a very good plane, I know. This is the big model, and this is the small model, let's say. And it says for every 5 centimeters, on the small one, it will be 2 centimeters. So for every 5 centimeters, it will be 2 centimeters. And if it says if the wingspan of the scale model is 28.5, so let's see, the scale model is right here. The scale model is the smaller one because that's what they're using to model. Let's make the wing a bit bigger to make it see. If the wingspan is 28.5, what is the actual one? What is the wingspan of the actual airplane? All right. So according to the proportion, the big airplane goes on the top, and you know data from the small airplane, so that would go on the bottom. You can take out the measurements if they make the math a bit too confusing. There you go. That's how the ratio of proportion would be set up. Now, use the same rule, multiply the 2 times the x equals 5 times 28.5. I'll do that on the calculator really fast. Which is going to be 142.5. Divide by 2, or multiply by 1/2. That's going to be, looks like that's going to be 71.75. Let me check. Yep, no, 71.25. So it's saying that if the small airplane's wing was 28.5 centimeters, the big one would have to be 71.25 centimeters. Don't forget the units. And I should have wrote this up here. Times around gym, and up here I should have said cranks on the pedal, because it said it's asking how many times to crank the pedal. Don't forget the units. You might lose points on that. And that is the answer.